Okay, so for our remote learners at home, here's the question. Basically, you're shooting a laser beam through a narrow vertical slit. This slit would be much smaller than the laser beam itself, and the question is, what happens when that laser beam comes out the other side and shows up on the whiteboard on the other end of the room? And so I'm going to demonstrate that real quick. We'll see what we see and draw some conclusions from that. I'm going to head to the back of the room and give this a try. I'm just going to do it the same way you guys did it. Alright, so let's see here. There's the laser. Oh, there we go. Yeah, this only works if you have the slit narrow enough. If it's not narrow enough, you're not going to see that horizontal spreading. So again, what we're seeing here is we're seeing this laser beam go through a very narrow vertical slit, and somehow it's coming out as a horizontal slit on the wall. So what the heck is going on with that? Wonder how much of that they could pick up. Okay, so any thoughts or guesses as to why we see this laser beam go from a vertical thing through that vertical slit and then it spreads out? Any thoughts? Try and think about what we've been doing this week. Maybe think about worksheet number 3 or worksheet 4 that I just passed back. Think there might be any connection to one of those. Yes? Not quite. Not just yet. Think a little bit more basic. What were you going to say? Come on. Okay. Yeah, nope, not that. That's a good guess, though. Because you are kind of changing the medium.
Oh, it's like when we did the waves going through this how they like not through the opening and they like curve through.
That is exactly 100% correct. If you look at worksheet number 3, when those waves went through that narrow opening, we kind of expected to see the waves just come out being narrow. But that's not what happened. The waves came out and they curved. They spread out. And so guess what happens when light goes through a narrow opening? Yeah, it curves. It spreads out in the exact same way that these waves do.
I was kind of right.
With crests and troughs?
No, with my thing because
Oh yeah. Yep. When you're talking about the scanner, yeah, the left-right, that's absolutely true. Yeah, so again, the main thing that we have to kind of think about here is in the same way that when waves go through a narrow opening, they spread out. They spread outwards in a direction that they weren't originally going. Light does the exact same thing. When it goes through a tiny narrow opening, it's going to spread out in the opposite direction that it was originally heading. You know, originally it came through a vertical slit. You'd think it would go vertical, but it doesn't. It spreads out the opposite way. It spreads out horizontally. In the same way that when we send waves through a narrow slit, they don't come out and continue this path. They curve and they spread out. And so this is one of the ways that light behaves like a wave. It has a wave-like behavior. They do kind of the same thing when they're passing through a small slit like this. Water waves will spread out and bend. Light will also spread out and bend. Questions on this? So this is kind of like the first half of the answer to the essay that you have to write for next week. How does light behave like a wave? In the same way that when waves go through a narrow opening and they spread out, light spreads out when it goes through a narrow opening too. And in the same way that the narrower the opening, the more these waves curve, the narrower the opening for light, the more it's going to spread out horizontally. So, there we go.